Okay, I wanted to put into perspective for you this concept of frequency and energy given off by electromagnetic waves. This is your EMR spectrum. We've been looking at the 5G cell tower issue, and all these numbers are thrown at us, like, 10 to the 9th, 10th, 11th, and we've taken our math classes, and we get that. We could write that number out, but the thing is, we really don't get it. These numbers are so big or so small, and with all of my gazillion years of living and teaching and the degrees I have and blah, 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 I really didn't get it. So I had to plot this out so I could compare it and understand it. So, don't feel bad if you look at these numbers and you're like, yeah, I don't care, because those numbers are just something I don't care about. But I do want you to understand it. Okay, so down on this side we have very high frequencies, and that means very high energy, because the faster it is, the more energy it is. And these are very small wavelengths. Okay, this is like 10 to the 12th, negative 12th meters. So that's taking it a yardstick and dividing it 1 billion times, and then dividing that 1,000 times more. So we don't even have a clue. This is, smaller than a nucleus here, or about the size of a nucleus of an atom. So these are where your gamma rays are. Very high energy. So 10 to the 20th. That's a 1 with 20 zeros behind it. And it's very, very high frequency. Now over on this end we have very low frequency. Like, just 1 hertz. And the wavelength is very long. Even we can't even imagine how long this wavelength is. 1 meter wavelength is like right in here, and this is a kilometer wavelength, and this is 10 to the 10th meters. Okay, so that's a kilometer times 10, 20, times 10, 100, 1,000, a million, times 1 billion or something. So these are very, very long wavelengths, which means a very low amount of energy. Okay, so we're focusing on the top here. Remember, over on this end right here, very high energy, very high frequencies. This end right here, low energy, low frequency. Now, at 10 to the 20th, in this range, from about 10 to the 16th or 17th to 10 to the 20th, right in here, we have what's called ionizing radiation. Now, if you remember from your chemistry class, an ion is something that's charged, and so when it reaches something else, it wants to charge it too. So that's why tissue damage can occur, is because you've got these little charged particles that are like, I want to react, and so I want to, react with your DNA, I want to react with whatever's in your tissue, your soft tissues like your eyes. I just want to get all into them. So this is not good. This is like super dangerous, bad, over on this end, okay? However, we do get exposed to ionizing radiation when we take x-rays. So there are different levels of x-rays. We've got like hard x-rays and soft x-rays. So we are exposed to some ionizing radiation. The thing is that the dosage we get with that radiation is very, very small. It's just a very small burst. Bam, you hear that little camera thing go off in the x-ray room. Now, people who work there all day, they have to leave the room so they don't get too much exposure. All right, now this is your UV range right here. So 10 to the 16th, 10 to the 15th hertz. Now, around 10 to the 15th, like this right here, this is the UV radiation. We are not able to see the UV radiation, but this is what causes our skin to get tanned. And so plenty of people are okay with going to the beach and getting this UV radiation, even though we know that getting too much UV radiation is linked to getting cancer. Still, that doesn't stop the amount of people that are trying to get suntans and going to the beach. Right here, between 10 to the 14th and 10 to the 15th hertz, this is visible light. This is the only thing that our eyes can detect and see. This is your Roy G. Biv, your red, orange, yellow, green, blue, indigo, and violet. This is what we see. And without this frequency here, which is 10 to the 14th hertz, that's a one with 14 zeros behind it, we wouldn't be able to see anything. Now over here is your infrared. This is about 10 to the 12th, 10 to the 13th hertz. This is stuff that we can't see, but it helps to keep things warm. So infrared radiation, we can feel that as heat, but we don't see it. Now down here, that's even less energy than all this, is microwaves and radio waves. So notice that the light that we see has about 10, 1,000, about 1,000,000 to 10 million times more energy and frequency than the microwaves and radio waves that we're talking about here. My microwave is right in here, and the range for communications from these towers that the FDA is considering to be safe is 10 to the 5th to 10 to the 11th. This is your range for your 5G cell tower frequency and energy. Notice how much lower it is than the visible light. Now I'm going to leave it up to you to decide. Granted, we are not going to put our head or our hand in a microwave and turn it on, because that will be very dangerous. We're right there next to the source. But the farther away that we get from the source, we close the microwave and it has safety switches on it, which you read about, then we're safe. But of course, if you were to get right up next to the source that's emitting these waves and stand there for a long time, that might be damaging to you. But they're towers, they're 5G cell towers. So I'm going to leave it up to you to decide whether you are in favor of these cell towers or not. But I just wanted to put into perspective the amount of energy that's